Hi, in this video I'm going to cover when using a custom trust store, how do we include the default cacert certificates as well. So we'll start with what is a cacert file. And cacert file is basically a trust store which maintains collection of trusted certificate authority CA certificate. So now what this line means is that if you go to any website, okay, so let's go to my site. So over here you will see that this is the website certificate, then this is the intermediate certificate, and this is the root certificate. So now what Java does is that with each update, they include all the registered root certificates and the intermediate certificate as part of the cert bundle. What that means is when you are trying to connect to a website or a URL, and the URL contains the SSL certificate, which uses a root certificate that is present in the cacert file, then you will not face PKIX exception. But if it doesn't contain that root or intermediate certificate, then you will face the PKIX exception. And the solution to PKIX is basically importing the root and the intermediate certificate. You don't need the site cert. So now let's read this again. So cacerts is a trust store which maintains collection of trusted certificate authority CA certificates or root and intermediate certificates. Now the default password for cacert file is change it. You obviously need the password to view the certificate that are in it or to import a new cert. Now the location of cacert, it depends on the JDK version. So like here in JDK 8, there will be a JRE, lib, security, and this is your cacerts. Whereas for JDK 11, it will be in lib, security, cacerts. Same for JDK 18, it will be in lib, security, cacerts. Yeah, if you like my explanation and videos, please do like and subscribe. Now let's talk about SSL context. Now the Java SSL context class is used to establish secure connections using the secure socket layer SSL or transport layer security TLS protocols. TLS is basically more secure version of SSL, and I'll add this link if you want to read more about it. Now it also provides method for configuring details and setting your own trust store and key store. We will basically focus on the SSL context, the set default method, which is a static method, and using this method comes with its own risk, because let's say if your application is running in JBoss, which has other applications in it as well, calling set default will impact all of these applications. But if it is like a Spring Boot that is a standalone app, then calling set default will only impact that application. It's basically, it sets the trust store and the key store at a JVM level. And so this value is shared. This also means if you're using your own trust store and you set it using set default, then only the certificates in that trust store will be used. And even so, if your trust store contains a certificate for a specific site, so let's say it contains just this DigiCert certificate. And if you go to google.com and Google does not use DigiCert, then you will get a PKIX on google.com. So the way to solve this issue is that you can have your own trust store and import your own certificate in it, but then you can at runtime, you can then import all of the certificates from the cacerts bundle. And that way, the site that you are trying to connect to will work along with the other sites as well. So in this section, I'm going to show you how using SSLContext.setDefault could impact your application if it is being used with shared JVM, meaning you're running JBoss or Apache Tomcat. So I have Apache Tomcat 10 here, and I have app1, which basically makes a HTTP call to the URL, and there's only one file here. Make a call to /info, and it will try and connect to untrusted root. So I'm expecting a PKIX. Then I have app2 here. When I call update, it will basically update the trust store and install the root cert from my downloads folder. So this root cert is the cert for the untrusted root, which means when I call update, it will install the root cert. And then when I make that call again on the app1 info URL, this should start to work and we should get a 200. But if I call reset, which will replace the root cert with another certificate and set that as SSLContext.setDefault, then in app1, we will start getting PKIX again. What this means is even though we are not making any changes to app1, but because we are updating SSLContext.setDefault, we are indirectly causing impact to the other apps. Copy, paste, say copy, paste to a CMD, go one folder back, go to bin, Catalina, start. So now we have the app1 and app2 deployed. I'll start with localhost app1 info. We get PKIX error. Then I'll go to localhost app2 update. And now we have installed the root cert untrusted root via app2, which is a separate var here, but it is using SSL context set default. So it is updating at JVM level. So if I reload, so now if I call reset and then reload again, see we get PKIX again. To update, it works. So now even though you are working in your app, which is app2, but because app1 and app2 are both deployed on the same Tomcat, and since app2 is updating SSL context set default, so that is why you are having impact on app1. And so you need to be mindful of this when using SSL context set default. So I have this project here, and here I have a class in which I pass the custom trust store path, password, and type. Now in this case, what I'm doing is I'm giving it a temporary path and I'll create it on the fly in a temp folder and then I'll delete it once the program stops. So we have a few methods here and then there's one method which actually makes the call. So now if we look at the test case, let's start with this one first, which says the test should fail since the root cert is not part of Java cacert. So basically we are just making an endpoint call. We are not adding any certificate. We are not passing custom trust store path where the certificate should be added. We are just making a HTTP call to the untrusted root. And it will fail because this actually throws PKIX exception. So if I remove the expected and then run it, you will see we get PKIX. Now, because I'm saying that I'm expecting the test to fail, that's why it passes in this case. So now what I've done here is I've said that get the temp directory, which will be percentage temp percentage in Windows or slash temp in Linux. It will basically create trust store here because I'm saying just get the temp directory and then create test key store, set the password to 123456. And what I did was I went to this URL and then manually downloaded the root cert and saved it here, which is this. So now in the second test case, I'm saying it should pass since root cert was added manually and set as default in the SSL context. So now over here, we pass the trust store details and we pass the certificate file name and we say set the custom store in SSL context. What this does is it gets the SSL context instance. You can actually upgrade to TLS 1.3. TLS is backward compatible, so that will work. And then we're not setting any key manager, but we are setting the trust manager. In trust manager, we are saying you create a key store, trust store type. I've set it to JKS. It is creating it in memory here. It iterates to the certificates. In this case, it's only one, and then it reads it and it sets the certificate entry. The alias is the file name and the certificate is the certificate data that it read from the file, and then it stores it in the path, which is the temp directory, and then uses the password that we gave it. Now that is done, then it sets the key store into a trust manager factory. We then set that to SSL context init, and we override the default value with this value. Now this value only contains one cert. Now what this means is this will work for this URL because it only contains the cert for this URL. So it works for this URL. If I do the same thing and try to call google.com now, because the cert is only the root cert, which is for this site, and by calling setDefault, we are basically overriding the cacerts bundle. So this thing, if we try to call Google, will actually throw a PKIX exception. See, and that's why I'm expecting an exception here if I use the same bundle or the same cert that I used for this one. Now, if I just call app and call Google, this should work because see, I haven't changed the SSL context. So it works because, and it returns the data from the website because I'm not updating the SSL context every time. When I run a test case, it is actually starting a new JVM instance which has the SSL context with cacerts bundle. But if I were to run these test cases, so like see in one, I'm overriding the SSL default, and then in other, I'm making a direct call. And if this one executes first and it fails, then if this one executes second, then this should also fail because it's basically the same thing. Because the SSL context method is static, once this set default is called, it will stay the same if we run these two tests together. But if I run them together, if I run the entire class together, you will see that won't happen. Like they all will run as if each of them were executed with a new JVM instance. So now the reason for that is there is a concept called before class in JUnit. And basically what I'm doing is before the class is loaded, right? Now before anything like anything here, none of this will work. Just this section, and it's static. So because it will run only once. So when the JVM is started and we are calling this class, this method will be called. When this method is called, I'm actually saving the SSL context get default initial state. So this is the state with cacerts bundle. And then what I do is now this before means it should run before the execution of each test case, right? Now in this before, I'm basically resetting the SSL context set default to the initial state, which was the state with the cacerts bundle. And then I make sure that the trust store, the temporary file is deleted. When I run the test case, they basically run with SSL context set default in a state where it only has the cacerts bundle. And that's why this one fails because the root cert is not part of it. And then this one passes because the cert was manually added. Then this one fails because it only contains the root cert of this website and not for Google. And now this one passes because the SSL context was reset by before. And so when this one ran, it got the Google root intermediate certificate from the cacerts bundle. Now, what if we want our program to pass for both the untrusted root via cacerts and for google.com? So now in that case, we will actually have to set the custom store. So in that case, we will actually have to write code to get the default cacert certificate bundle, add them to our custom store, and then set it as the default store. So if I run this one, this will work, and we'll go through the code now. See, it works, and let's do a assert true or equals that we got a 200 from here. So if I run this, say dot status code. So if I run this, so it passes. It got response from both the URLs. So let's look at how do we do this. So we can use TLS, and over here what we will do is, see, we will get the key store where the key store will have the cacerts. Then what we will do is we will get another instance of Trust Manager Factory with a default algorithm, and we will initialize it as key store being null. Then what we will do is we will say, give us all the trust managers that you have. It will give us a list of trust managers, and we only want the X509 trust manager, which means we are looking for certificate entries only. And then we get them and we collect it as a list. Once we have the list, we iterate through the list and we add it to our key store. So key store requires a alias and the certificate. Now, in order to get a unique alias, I've simply used certificate.getSerialNumber, and then I store the key store to the same path. Now, this key store has the root cert that we passed and also the certificates from the cacerts bundle. And then we will set it, we will get another trust manager factory, and then instead of initializing key store as null, this time we will initialize it to our key store, and then we will simply return this trust manager factory. Now, when we return this trust manager factory to the SSL context here, it will get a new instance, right? So we are still, so this one has nothing to do with this line, right? So we're basically saying, give us a context, it gave us a new instance. Then we initialize that instance with the key store that had the certs, the root cert, and the certificate bundle. And then we override the SSL context at default with this context. Now, because it has the certs and the default cert bundle, the code is able to connect to both the one that requires a custom cert and google.com. Now, this example was with SSL context, but there are other ways of doing this as well, including how do you reload at runtime, but keep the scope small. Also, how do you have multiple trust stores? But I will cover those in a separate videos with in-depth test cases. Hope this helped. Thank you for watching.